All right. So by the end of this lesson, you will be able to convert between weight and mass, incorporate numbers in a free body diagram, and use the free body diagram to compare magnitudes of forces. All right. Set it up. It's on you. Set it up. Steps 1 through 5, just like you did. Beat me to the end. Make sure you look up occasionally. Make sure you keep it. Okay, I'm going to make down the ramp positive. You can make up the ramp, doesn't really matter. But you need to tilt your axis. Okay. Whatever this angle is, that's the same angle between the new y-axis and the force of gravity. Had her day.
I'm curious, how does it equal 0 for the fx part?
It's F.
Oh, exactly.
It's doing what inertia wants to do.
Yeah. Okay.
Huh? Okay. How'd you do? Grade yourself out of 5 points. The setup.
So how do we answer how much friction is present? Like,
Great question. To be continued.
Okay.
Okay, but notice I gave you numbers, but we haven't touched numbers. Okay? I want you to do the same thing on tonight's homework. Set it up. Don't freak out like, oh, which equation should I use? Like, don't ask yourself that. Don't start by picking up your calculator. Start by setting this up. Okay? That's why we spend so much time on the setup. Don't forget that. Okay? So, we are now ready to incorporate numbers. What is the question asking us to find? Friction. Where do we find friction in our setup? Right here. So if we can find this, we've got our answer. Does that make sense?
Yeah.
Okay. So can I just take this and stick that right in there? No. I first need to find force of gravity, right? Because that's the component. Okay. Can I, is force of gravity 60? Force of gravity is 60. Tell your neighbor why or why not.
That's just mass.
Okay. What's the unit for force? Newtons. Right? Newtons, sorry. Any type of force is measured in newtons. What measurement is measured in kilograms? Mass. How do we convert between force of gravity and mass?
Oh, 9.8.
We use the equation that was on your pre-quiz. Okay? So we have force of gravity is equal to 60 kilograms times 9.8 meters per second squared. Now, quick little disclaimer here. This is just an equation that converts between kilograms and newtons. This does not say anything about how it's moving. Okay. This 9.8 does not communicate how anything is moving. This is just the number that we use to convert between kilograms and newtons. It's like using the number 12 to convert between inches and feet. Is something 12 something long? No, that's just the unit. Sorry, it's just the number that we use to convert between inches and feet. 9.8 is just the number that we use to convert between kilograms and newtons. Okay? That's why we didn't put an A here for acceleration. This is just G. This is just the magnitude of that, just so we can use that number to make that conversion. You okay with that? Okay. It's just an equation. So, can I stick 588 in here?
Yes. No, we have to add the sign.
Okay. That's equal to this guy. I need to find the x component of that. Tell your neighbor what trig function you're going to use to find FGX.
Sign.
really?
Okay. Do not memorize that x goes with cosine and sine goes with y. Always look at your triangle. Okay? We're looking for the opposite side. So we're going to use sine. Sine of 32 is equal to f gx over 588. F gx is equal to 312 newtons. Okay with that?
Yeah.
Can I stick 312 and stick it into here? Yep. 312 newtons is equal to my force of friction. Well, we didn't touch the y side. You're right. Not yet. But it's there for us to be used in the coming future. Okay? Now, there are, just in general, there's a lot of little steps. If you can do the setup and you can be organized, it will go well for you. Okay? Ready to try another one? Any questions on this before this goes away? You see how we're doing the setup first and then using the setup. Okay. We're going to assume this guy is going to go on the horizontal track. We'll say this is our, and pushing it to the right. How did I know that some of the forces in the x direction are not equal to 0? More specifically,
It's speeding up.
it's experiencing acceleration. Okay? Is it possible for an object to be moving and the sum of the forces be equal to 0?
Yes.
When would that be the case?
Constant velocity.
It's doing what inertia wants to do. It's moving at a constant velocity. Okay with that?
Yeah.
Okay, but here it said it started from rest and is now moving. So like it's not doing what inertia wants to do. Applied force minus friction is equal to mass times acceleration. Here you have normal force minus force of gravity equals 0. How do we do? On the setup. Okay? Okay. Now, ultimately, what are we looking for? The question we're asked to solve for is distance. How far? Where in my setup do I say anything with distance? Mr. Smiley, you lied to us. Like, there's nothing about distance in my setup.
Acceleration.
True. But I do know, motion-wise, I have 3 seconds. I have started from rest. I have, and I'm looking for how far. What on my setup incorporates something with motion? We have acceleration. So if I can find acceleration, that will give me the third piece of information I can do to figure out and use a kinematic equation, yes?
Yes.
To find how far. Okay? So I'll give you a head start. See if you can beat me to the end. Let me get some kinematic equations here.
Did you get 6.6?
We all did. It's the answer. Well, could you put it into that, right? Well, I'm getting six. Well, apply is that max is 0 minus the force is 2. So yeah, 5 here.
Okay. So here's a kinematic equation. You found that to be 7 newtons minus 2 newtons is equal to 0.75 kilograms times acceleration. Acceleration is 6.67 or roughly, yeah. Okay. Okay. So we're going to choose third. Okay. starts at rest. 1/2 times 6.67 times 3 squared. If you don't round, you get 30 meters. How did you do? Did you do it yourself? Great question. I'm looking for distance, and like all of these, I mean, I can give you the easy answer is it's going to be in meters because it's distance. The official answer is I've got meters per second squared here, and that's going to cancel out with squared seconds here, and we've left in meters. Okay. All right. One more example problem. Set it up.
It's just my own. On the homework tonight, will you provide us with the box and line already?
Will I provide you with what?
Like just like the box and with the free body diagram, or like, but we just have to draw the line, so we also need to set up the box.
You need to do box. Like I'll give you a picture, and then you do the box.
Okay.
It's almost here. Okay, here is the applied force. Notice that it's from the vertical, this angle. So the 40 degrees is from the vertical. Does that make sense? How I'm measuring that. Make sure you have your free body diagram right before you move on. And make the right positive, up positive, some force in the X direction. Okay, real fast, the sum of the forces in the X direction, are they equal to 0?
No.
Okay, it doesn't specify what the motion is in the horizontal or in the X direction. Okay, Saying that the sum of the forces are equal to 0, that's a special case. That's either at rest or moving at a constant velocity. We weren't given really any details regarding it. We were just saying it's standing across the ceiling. Okay? So if you're not sure, set it up not equal to 0. Okay? Because equal to 0 is a special case. How did you do on the setup?
I've never seen it.
Okay. All right, beat me to the answer. How did you do?
I got two.
Okay, did you remember to do this? Convert to newtons. Okay. That's what your homework's going to feel like. Good. Okay. Again, my suggestion would be organized. Any questions, points of confusion?